morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today we are going to learn about the problem solving on hypothesis testing. So here we will see one by one questions. First question is that in the population, the average IQ is 100 with standard deviation is 15. Team of scientists wants to test a new medication to see if it has either a positive or negative effect on the intelligence or not effect at all. A sample of 30 participants who have taken the medication has a mean of 140. Now the question is that did the medication affect intelligence? We have to find out the answer of this by using the hypothesis. So we will see this problem how we have to solve. We will see here stepwise. First step is that set up the null and alternate hypothesis. You people know that here we have to set null hypothesis and the alternate hypothesis. First, H naught is your null hypothesis and HA is the alternate hypothesis. H naught is showing that medication affects intelligence and HA showing that medication does not affect intelligence. So here we have assumed that H naught as a medication affects intelligence and HA medication does not affect the intelligence. Not that the alternate hypothesis is always opposite of the null hypothesis. So in first step, you have set up the null and alternate hypothesis. Then second step, you have to determine the type of test to use. Which type of test you have to use here, we have to decide first. First, since the sample size is 30, here already given that you have a sample of the 30 participants. That means our sample size is 30. So here we will use the Z test or Z test. The Z test is used when the standard deviation of the distribution is known or when the sample size is large, usually 30 and above. That means when you know the distribution value, at that time you can use the Z test. Now the step 3 is calculate the tested statistic Z using the formula. So Z test formula is that Z is equal to X bar N minus mu naught divided by sigma divided by square root of the N. Here mu is showing that null hypothesis to be tested. That means the given. Then sigma is showing that the given standard deviation. N is that the number of sample. Xn bar is the mean of the samples and Z is the tested statistic. Then this formula can be written as Z is equal to Xn minus mu bar divided by sigma into square root of the N. Using the data in the equation, we would have the following. Now mu naught is 100. Our average IQ is 100. That means your null hypothesis that is given the mean is that 100. Then sigma, that is your standard deviation, it's a 15. Sample size is 30 and Xn bar is 140. Now we will keep these values in the formula and now we will solve. Z is equal to 140 minus 100 divided by 15 into root of the 30. After keeping these values, we will get the Z is equal to 14.606. So after that, we will see the step 4. Now we have to search for the values of the Z. That means we can say that is the critical value from the statistical table. And from the table, we will get the value of 1.96. Now after that, we will we got the conclusion. In this case, the tested statistic value of Z calculated is more than the critical value obtained from the statistical tables. Our critical value is 1.96 and our statistic value is 14.606. So here 14.6 is greater than 1.96. So therefore we reject the null hypothesis. This means that from the question the medication administered does not affect the intelligence. If these values, if statistical value is less than the your value, statistical table value, so at that time we can consider that medication is affected the intelligence. But here we will reject the null hypothesis, and after that we got the we reached to conclusion that medication administered does not affect the intelligence. Now second question is that a professor wants to know if her introductory statistics class has a good grasp of basic maths. So 6 students are chosen at random from the class and the given math proficiency test. The professor wants the class to be able to score above 70 on the test. And the 6 students get the following score, that is 62, 92, 75, 68, 83 and 95. Now, can the professor have 90% confidence that the mean score for the class on the test would be 70%? So let's see how we will find out. First solution. Now we will recommend that you have to read the question number of times and then you have to understand which points you have to find out. First, again we will check. Professors wants to know her introductory statistics class has a good grasp of basic maths. She chosen 6 students randomly, and she wants the class to be able to score above 70 marks in the test. Now 6 students got the score like 62, 92, 75, 68, 83 and 95. But after that we have to find out, can the professor have 90% confidence that the mean score of the class will be above 70? So here there is need to find out the variance which is not the given. Then sample size is 6 and the mean score that need to be tested is 70. Now first step is that you have to set up null hypothesis and the alternate hypothesis. Null hypothesis means H naught is the 100 and HA is the less than 100. If null hypothesis requires that mean to be greater than 70, then for the alternate hypothesis mean should be less than or equal to 70. If null hypothesis required to be greater than 70, then definitely alternate hypothesis should be less than or equal to 70. Now second step is that determine what type of test to use. From the question, sample size is very small, that is only n is equal to 6. So just the variance is not given, but in this case we will use the t-test. In previous example we used z-test, but in this example we will use the t-test, that means one sample t-test. And then step 3 is that calculate the mean of the sample. You can calculate the variance of the sample using the formula below. X n bar is equal to summation of I is equal to 1 to n and xi. Now here we will add whatever we got the score, that is 62 plus 92, 75, 68, 83, say 95, and divided by the 6. After that, after solving, we got the mean 79.167. So our x and bar value is 79.167. So step 4 is that calculate the variance of the sample. Now we have to calculate the variance. Here SD square is equal to 1 by n minus 1 summation of I is equal to 1 to n xi minus xn bar whole square. Now this would give us value of 173.38, and this is actually the variance. Taking the square root would given the standard deviation as a 13.167. Now step 5 is that calculate the tested statistic t. For t test, we will use the t is equal to xn bar minus mu 0 divided by standard deviation into square root of the n. This would give us, we will keep the values. Our xn bar value is 79.167. Then after that, mu 0 is, that is 70, that means average mean. And the standard deviation is 13.167. So, and n value, square root is, n value is n is equal to 6. Now, after solving this, we got the t value 1.705. Now, step 6 is that check the value of t in the table. Now, question specifies 90% confidence. Already your question has declared that 90% confidence. So, we have to check that degrees of freedom. Now, degrees of freedom is n minus 1. Your n value is 6. So, 6 minus 1 is 5. And from the now statistical table, our critical value if t is given as 2.1328. Now we got the conclusion that the calculated value of t is less than the critical value. Your t value is 1.7 and your t value is 1.7 and the critical value is 2.1. So in this case, we accept the null hypothesis. So the professor can be confident that the mean score of the class can be 70. In first test, we have compared with the z test. Here we compared with the t test. Now question 3 is that how to perform paired sample t test. A clinic provides program to help their clients lose weight and ask a consumer agency to investigate the effectiveness of the program. The agency takes the sample of 15 people, weighing each person in the sample before the program begins and 3 months later. The results tabulated below, person below, after and difference they have given. So determine the program is effective. There are 15 number of person. They have the before values, after values and the difference values. Now first step is that set up null hypothesis and a alternate hypothesis. From question we can say that initial assumption is that the program effective. We will say that initially your program is effective, which means that average weight after the program would be significantly different from the before program. And this forms out alternate hypothesis, and the null hypothesis states that there is no difference in the weight before and the after program. So H naught, that means null hypothesis mu naught is equal to mu 1 and the alternate hypothesis mu naught less than or equal to mu 1. Now step 2 is that expand the given table to calculate the difference and the square differences. And for this we will use the Excel sheet. And there is your table. There are some columns like person, before, after, then sigma, d sigma, observations are there different. So all things we have to find out. Here mean is that 10.93 and 5.60.93 and divided by, and the standard deviation is 6.33. Now in this case, table have been extended to accommodate and difference between the two tape sample, difference between from the mean and the square of the difference from the mean. Now third one is that you have to calculate the standard deviation, and for that you have to use the SD square is equal to 1 by n minus 1 summation of d minus d bar square. If you put the correct values, so you will get the standard deviation is equal to 6.329. Now calculate the t tested statistics. You have to calculate the tested statistic t using the formula. Here t formula is d bar standard deviation into the n square root of the n. So we can transfer this this square root of the n below standard deviation. So we can use, if you use the values given, so your t value will be 6.6895. Now the step 5 is that look up the value of t from the statistical table. Now value of t using the degree of freedom of 14, that is n minus 1, and the 0.05 n minus, here n is equal to 15. So 15 minus 1 is equal to 14. So your degree of freedom is the 14 and 0.05 is your significance. Now you have to compare it with the calculated value of the t, and from table we got the t value is 2.1448. Now we reach to our conclusion that when you compare the calculated value of t with tabulated critical value, so at that time your t calculated t value is greater than 2.1448, and so in this case there is significant difference in the weight after the program. Therefore we will reject the null hypothesis. Now fourth question is that a study was performed to test whether cars get better mileage on the premium gas than on regular gas. Each of 10 cars was first filled with the regular or premium gas decided by coin toss, and mileage for the tank was recorded. The mileage was recorded again for the same cars using the other kind of the gasoline. Now determine whether cars get significantly better mileage with the premium gas. So here they have given the mileage with the regular gas and the mileage with the premium gas. Now we will see how we will solve. So first step is that first you have to set up your null and alternate hypothesis. Here again null hypothesis, in a null hypothesis your mu2 is equal to mu1, and the alternate hypothesis is showing that mu2 is not equal to mu1. Then second step is that you have to create the table to calculate the difference. And if you have entered the data and the formula correctly, you will have the table below. There is a regular gas entries, premium gas entries, then d value, d into sigma, d into d bar, and d minus d bar. So after that you got the mean to here 18 and the standard deviation 1.414. Now notice there is a mean and the standard deviation, and the step 3 is that you have to calculate the mean of the difference from the table. Now from the table mean difference is 2, we have already got. Now step 4, calculate the standard deviation of the differences. Now this means this can be gotten using Excel very easily, but in this example We calculate it using the formula and we can see that it corresponds to the one in the Excel sheet. Now you have to use the formula standard deviation square is equal to 1 upon n minus 1 summation of d minus d bar whole square. Now we have standard deviation is equal to standard deviation square is equal to 1 upon 10 minus 1 into the 18. Now you got the standard deviation square 2. Now you have to calculate the standard deviation is equal to square root of the 2 and your value is 1.44. Now calculate the standard error. You can calculate the standard error using the formulas SE of d bar is equal to SD upon square root of the n. So here SD value is 1.414 divided by square root of the 10. So here after solving this formula, after solving this answers, you will get the standard error of d is equal to 0.4472. Now step 6, you have to calculate the t statistic and we calculate t statistic using the formula t is equal to d bar upon SE of d bar. Now d bar value is your 2 and SE of d bar is 0.4472. After dividing this, you will get the value 4.4721. Now look up the t statistics from the table of the t distribution. Here you have to check again statistical table, and from the table of the t distribution we find the t using n minus 1 is equal to 9 degrees of the freedom and 0.05 significance. That means that gives us 2.262. Now step 8, you have to compare the tabulated value and the calculated value and you have to reach to your conclusion. Now we see that the calculated value of the t is greater than the critical value of t. This means that there is a significant difference in the means of the two samples. So therefore, we reject the null hypothesis that states that the two means are equal. So this is all about the problem solving on the basis of the hypothesis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.